Welcome to question number 36, the last one from the June 2017 Geometry Regents exam. We have Frida, who is training to use the radar system. She detects an airplane flying at a constant speed and heading in a straight line to pass directly over her location. She first sees the airplane at an angle of elevation of 15 degrees. So you can see that I've drawn a diagram here to kind of help us visualize what's going on. So this angle of elevation is 15 degrees. And it also says that it's maintaining a constant altitude of 6,250 feet. So this vertical distance here is 6,250. I think, oh, by the way, we're just going to kind of ignore the fact that she is also, not laying down on the ground. But 1 minute later, she sees the airplane as at an angle of elevation of 52 degrees. So now this larger angle here is 52 degrees. But we also know that it still has that same vertical height of 6,250. So you can see we have two different triangles here to deal with. And the question is, how far has the airplane traveled to the nearest foot? So what we're looking for is the distance from here to here. Now the strategy we're going to use is that we're going to find this total distance from here to here, and we can do that by using the green triangle I drew, and then we're going to subtract the distance from here to here, which we can find using that white triangle I drew. And we can use this using a trig ratio, specifically the tangent ratio, because we're dealing with opposite and adjacent sides to the angle that is given. So tan of 15 degrees is going to equal opposite over adjacent. So opposite is 6,250 over x, because we don't know. And so that x would be this long distance here. So to find out what x is in this example, we're going to kind of flip the positions of these guys. So x is going to be equal to 6,250 divided by tan of 15 degrees. 23,325.3. Now we're going to use a similar strategy to find out this distance here of this white triangle, and we'll call that y instead. So to find out y, we're going to be using the exact same numbers, except it'll be tan of 52 degrees. So we're going to do 6,250 divided by tan of 52, which is 4,883. Now that we have those two numbers, we're going to subtract them. So x minus y, we'll call this distance z, is going to be found by subtracting those two distances. And that gets us 18,442 feet, because we do want to round it to the nearest foot. Now for the final part of the question, we need to find the speed of the airplane. I'm kind of running out of room, so let's just zoom in over here. So what we already know is that the plane is traveling 18,442 feet per minute. And we know that because we were told that it travels, that's how far it went in 1 minute. But we just need to convert this into the proper units that they want, miles per hour. We can do that with some multiplication here. So we want to first change feet into miles. So we know that 1 mile is equal to 5,280 feet. And that will work by canceling those two out. And then we need to convert minutes into hours. And there are 60 minutes in 1 hour. And by setting it up that way, we can also cancel out these minute units, and we'll be left with miles per hour. And to find that number out, you can see what we're going to do here is 18,442 divided by 5,280 times 60. And that gets us our final answer, a rounded answer of 210 miles per hour. All right, that's all for this video. Hope that was helpful, and thanks for visiting JD's Regents Preparation.